Conference is titled State of the Algae Industry. And I'd like to introduce our speaker, Dr. Fengzheng Gao, a microalgae researcher, ETH Zurich, Switzerland. He'll be speaking about microalgae industry in China, biomass production and application. Please welcome him on stage.
Good afternoon, everyone. So I'm waiting for my slides. So I'm very happy to be here. First time to visit Saudi. My name is, My name is Fengzheng Gao. I'm from China, but I'm working in Switzerland, ETH Zurich. So today I'm talking about microalgae industry in China, biomass production and applications. So first, briefly introduce my research before the topic. So my current research is about microalgae in human nutrition and health. It's a very important topic because we can use microalgae for humans, for health and nutrition. And I work with two different groups at ETH Zurich. One is sustainable food processing group. Especially we want to use microalgae as a sustainable food. Then I also work with nutrition and metabolic epigenetics group. So in this group, we want to understand the complex relations between the nutrition and microalgae compounds. So we have a quite new important research line from microalgae biomass production using different photobioreactors. Then we have different processing techniques to improve the bioaccessibility of different microalgae compounds. Then we have the in vitro methodologies to test the bioaccessibilities, and we have the ex vivo human cells to test the absorption of different microalgae compounds. And following, we can use animal models to test the in vitro bioavailability and bioactivity. And we also have planned to do clinical trials because if you want to use microalgae for human health, we need clinical trials. And we also have connection with big companies like Nestle, Givaudan, and Buller for products development. So I have two research assistants. We have three professors supporting this important topic, and Professor Alexander Mattis and Professor Ferdinand von Meyer. And we also have advisor and collaborator from University of Oxford, a leading expert in human nutrition in the world, Professor Michael Zinnemann. So I had 10 years experience working on microalgae from different topics. So I worked in China before, in a coastal city called Qingdao for 8 years, from Ocean University of China. It is the top one university in China for aquaculture and fisheries. And then I moved to Wageningen University, Netherlands, to work on microalgae stream improvement for 5.5 years. After that, I got funding from European Molecular Organization to do research in Portugal with the institute and microalgae companies. And I also visit shortly to University College London and University College to do collaborations with them. And after that, I back to Wageningen to do a postdoc. And then I moved to Switzerland for my current research. Since 2014, I'm a member of the China Industry Algae Association and a member of the Qingdao Microalgae Academy. So when talk about microalgae industry in China, there are many first expressions about China, a lot of things, I believe you know. But actually I want to highlight the microalgae. Actually, China is the major producer of microalgae biomass in the world. It is producing approximately 70% of the biomass in the world, the microalgae biomass. I want first to introduce the history of eating microalgae in China. Why we have a huge algae industry? Because the Chinese people eat algae, not only seaweeds, but also microalgae. For instance, on the top, you can see the microalgae, the seaweeds. We have a lot of food made with seaweeds. when I was a student in Qingdao, I ate a lot of seaweeds in the university. And also for microalgae, actually we have a long history about microalgae consumption. For instance, 1,500 years ago, there was a guy called Ge Hong, and he used nostoc from the rice field as a Chinese traditional medicine. So long history of consumption of microalgae also. So here, before I talk about, I'm not a seaweed expert, but before I talk about microalgae, I want to also give some numbers for seaweeds here. The seaweed production in China. We have a huge seaweed industry, like million tons. So different types. So, and this is not enough. We still need to buy a lot of seaweeds outside China, from outside China. So there's a huge potential for it. The demand is very high. Then for microalgae development, microalgae industry, I have to tell you that it took us 60 years to have the current microalgae development. It's not like suddenly in a few years we have this industry. So in the 1960s, at that time, we need food. So the government supported some scientists to grow chlorella for humans. Then after that, 1985, we started the spirulina industry, and 1988 for the donulina cultivation. And this is period, the development is relatively slow. Then after that, from 2000, especially the last 25 years, the development is quite fast. So we have several different microalgae that's approved as novel food. For instance, the Haemotococcus, Nanocropsis, Chlamydomonas, and so this all species approved in the last 20 years. So the development is very fast. So this is a table about the microalgae approved already in China as novel food. For spirulina, it is a normal food. So it's not novel, it's a normal food. People can eat them without limitations. And for other, let's say 7, it's approved as novel food. And especially, for instance, in the last 2 years, we have Nanocropsis and Chlamydomonas approved. So the things are getting much better and the industry is getting bigger with more species approved as novel food. And there are a lot of business based on we have around 150 companies in China produce microalgae for different business purposes. For instance, here you can see, actually almost all of the provinces in China, they have microalgae production. And almost all of the universities in China, we have researchers working on this topic, microalgae. And from south part of China, for instance, in Hainan province, in Guangdong province, they can produce the microalgae the whole year round because the weather is good. And in middle part of China, they can produce half year. And the north part of China, less than half year even. It depends on the weather and depends on the species. So I will briefly introduce some examples of the companies in China. We have so many companies, I don't have time to introduce them all, but some companies that can produce relatively more biomass. For instance, this is the spirulina production. The biggest production base is in north part of China, in Mongolia. And you see it is quite north, the weather is not so good, but they use very simple techniques, the greenhouse, to produce spirulina with 4,000 tons per year. This is a dry weight. And also in south part of China, there are several companies like Fengzheng Gao, they can produce more than 1,000 tons per year. And they have also products, the pills, the powder. They have different products also. And I also want to highlight a bit, in recent few years, we also have you see that the big companies, they use open response, quite easy, quite simple. But the recent 2 years, 3 years, there's few companies that start to use photobioreactors for spirulina production because they want to sell the fresh biomass, because this is quite nutritional. People can just eat the fresh biomass. So this is a relatively new product in China. And in the Mongolia, this is example, the greenhouse, very simple, but it works. It works quite well. And when we put the greenhouse, the algae farmers there can produce algae for more than half year, and during winter they can do the maintenance in a very good way. So this is how they become the biggest algae production sector in China. And they also get support from the local government. They have very nice organization from the local government. They have 40 companies, approximately 40 companies, they are working together there. Then the second major commercial microalgae, chlorella. There are two different types. One is heterotrophic, use fermenters, use big fermenters for heterotrophic production. And another mode is photoautotrophic production, mainly in south part of China. Then for Haemotococcus, this is the only commercial algae that we have to use photobioreactors in China. At the beginning, we also did a lot of trial, use open reservoir ponds, but the productivity is too low. So then we use reactors in Yunnan province. You see the south part of China, they have mountains there, they have good weather. So the photobioreactors are all over the mountains. So there are many big companies, they can produce a lot of Haemotococcus. And they also extract the pigments, the exoxanthin as commercial products. And for instance, there's one company like BGG, their photobioreactors in total is 1,000 kilometers, so in length. So quite a big industry in that part. Then Dunalina is a relatively smaller microalgae compared to other species because the cultivation conditions is a bit tricky. We need the salt water for that. But still, we have a few big companies, they can produce 40 tons of the Dunalina each year, mainly in the north part. Why? Because north part, especially in the Mongolia province, they have some salt licks. So they have the natural environment for Dunalina production. And also the companies, they also have some products in the market. Then I want to talk about the recently approved two microalgae species. The first one is Chlamydomonas. There's a big company, big group in China. They collaborated with treating algae innovation, and they put a lot of money to produce Chlamydomonas in fermenters and huge fermenters. And their target is they could produce 4,000 tons per year of Chlamydomonas. And I believe China is the first country to approve Chlamydomonas in the world. And they want to replace the protein. And another species is Nanocorpis. So several companies, they are producing Nanocorpis for aquaculture, for food. And you see the sector in the south part of China, in Guangxi province, they have 2,800 hectares to produce Nanocorpis. And they have the products in mainly about EPA, the omega-3 fatty acids. And then this is a nostoc. It's still microalgae. It looks like a ball, but it's still microalgae. They are aggregated together. And in general, you see the traditional productions from the left side. People, actually the local farmers, they harvest from the rice field because this microalgae can fix the nitrogen to provide the fertilizer for the rice to improve the rice production. And now they also have some artificial way to produce these species in recent few years. They improve the technique, and they can produce artificially. And the current production is around 350 tons of the wet wheat. In general, this is wet wheat for the dishes. And then in recent few years, we also have the Igluna that produced in China also by the fermenters. We don't have a specific number yet, but we expect like 50 tons per year, the dry biomass. But it's also a novel food in China, so we expect also a large space in the future. Then, of course, there are also some associates in the business about microalgae. For instance, there are many companies, they provide the techniques. They teach people how to grow microalgae. They provide the technique and the strains. And also there are some companies, they are producing a drinking machine with spirulina inside because we can drink spirulina in our daily life. And in the right side, you can see the photobioreactors. There are also photobioreactor companies, they produce different tubulars for different skills, from research to industrial. And the left, you also see some cosmetics. And the middle, just an example, there are also some companies use microalgae to feed the chicken. Then you can have more DHA or EPA, like 6 times higher in the eggs. So this is quite nutritional. And the price is much higher than the normal eggs. Then I will talk briefly the bottlenecks, the challenges. So first, quality and safety. We have so many companies. We need to control the quality and the safety, and the way is to have some standards. In the recent 5 years, the organizations are working very hard to set the standards. So all the companies need to follow the standards to improve, to follow the same standard to provide the biomass with good quality. Then the second one is the precise application. If you want to tell people why you want to eat microalgae or why you want to use microalgae for your industry, for instance, for aquaculture, you need to tell people what is the specific function, what is the benefit if you use microalgae. So we need to do more research to prove. That's what I'm doing in ETH Zurich to approve the functionalities of microalgae for humans, for the nutrition and health. And the third part is, I think, is a problem for the whole world, the marketing and the communications. We need to tell people to open the market. And then cost is always a topic that we want to reduce the cost. But personally speaking, I would also say that we should improve the production value. Then we can get more profit even. So reduce the cost is not only way to have a bigger algae world, but if we can provide the products with much better quality, people would pay more. So this is a future perspective. For instance, this is in China. We have approximately 12,000 tons in total of the dry biomass. What can we do? We think there are many directions for human nutrition products, for animal feeds. We have a huge demand, more than 200 million tons per year. This is a huge demand. And then also for CO2, the recent few years, this is a hot topic, and wastewater treatment. So we can also use microalgae for different kinds of wastewater treatment. So just few small examples. For instance, aquaculture. This is the number in China. What is the aquaculture volume in China? We have 53.9 million tons of the aqua products from aquaculture. So 80% of the total aqua products from aquaculture. I think China is the only country in the world, this number is more than 50. We have 80%. We have a large population and we need the fish. We need to feed the population. And it works quite well. The city where I graduated and where I worked before at Qingdao, we have a large aquaculture industry. And the Ocean University, they have a lot of technology to support that. And we can use microalgae for fish. In the right side, I show you some family, very easy, very simple family tanks. You see, this is very simple. And to be honest, we cannot summarize the biomass from these tanks because they are from the aquaculture industry. They don't summarize their biomass, but they use a lot. They just grow the microalgae. They don't care too much about what is the productivity. Then they pour the algae to their ponds, and it works. So this is quite something. And in recent years, that there are some commercial companies. They start to produce some commercial aqua feeds with microalgae. You see the concentrated microalgae, and they are doing good business, I can tell you. So in the future, we want, if we can have some commercial professional companies, they can produce these products for the aquaculture. Then they don't need the family tanks to have a very low productivity. Then we can improve the industry. And then some commercial products like phycocyanin, a very functional blue pigment. It has been approved as a food additive in 2019. For instance, this company can produce 200 tons per year. So because it has been approved in the recent few years, and we also expect huge potential. And for CO2, there are large projects in recent years in China, because this is a topic, this is the aim of the government to reduce the CO2 emission. So I have one very simple, a few words like a small microalgae, big potential. I'm still young, I'm a young engineer. I believe micro has a huge potential in the future, and I will for sure work for it. And there are a lot of companies, they are not here in China, but they provide pictures, they support this conference, and they are open for collaborations. And also I want to thank the organizers So thank you very much for the attention, and welcome to China, and welcome to Switzerland.
Thank you indeed. Our second speaker is Dr. Gabriel Assing, Vice President of the European Algae Biomass Association, University of Almeria. He'll be speaking about the state of the microalgae industry in Europe.
Hello again. I will talk now about a more technical topic. It's about the status of microalgae production, of algae production in Europe. It's very interesting to have the previous presentation from Professor Gao, because more or less in Europe, we are facing the same problems that in China, but probably we are more focusing in improving the quality of the biomass we are producing, because the companies already in this sector are more interested in this type of application. I want to remark that, to say that I come from Almeria. Almeria is a desertic area in the south of Spain. Spain is in the south of Europe. Then the weather is not so hot like here, but more or less the landscape is quite similar. We were able to transform this area in a very productive place, producing vegetables for Europe. And today we are exporting these products around the world, especially in Europe. And it's a very small region, it's more or less 200,000 inhabitants. We are producing more fruit than entire countries like Mexico, Netherlands, or other similar food producers. I want to remark that this was performed by improving the technology. Then the technology is the way to be able to adapt to the places, to the conditions, and to be able to take advantage of them. Also, I am part of IABA. IABA is the European Algae Biomass Association. Victor is already part of this association. Carlos Unamunzaga, Jean-Paul Cadoret will talk after tomorrow about that, about this topic, and myself. The European Algae Biomass Association is a very interesting association integrating companies and research centers, including individuals. It's a very interesting tool to establish collaboration with the European Commission and also to put together the efforts of the industry. I want to recognize that the industrial sector in China is probably much bigger than in Europe, but in Europe we have a very close collaboration among the companies, and we are trying to improve this sector. The European Algae Biomass Association is well connected both with the industry and also with the research projects. Then you can find a lot of information about the most relevant projects being developed in Europe, related with seaweed and also with microalgae, but also the connection with other associations around the world, especially in Asia, in the States. I think this type of collaboration is very important to move on this sector. And here you can see the large number of companies and also scientific research centers and individuals, more than 200 members of the society, of the association, sorry. And I will not enter in all the brands, all the companies working on the topic, but believe me that all of them are growing. All of them are focusing on increasing the production capacity, and especially to increase the quality of the products and to open new markets for the algae-related sector. This slide is, I take this slide from Victor, because the association is focused both in microalgae and seaweed. I will provide a short overview of main topics about algae production in Europe. This is the typical production of macroalgae in the oceans. This is a well-recognized technology, but these production systems have certain limitations, certain bottlenecks. Some of them are related with the environmental impact that we are providing or we are performing in the ambience, and also we have certain limitations in the amount of biomass and the quality of the biomass that we obtain when we harvest this material from the oceans. This is the reason because a lot of companies are moving to the inland production. I mean, to be able to produce a specific seaweed strains, not at only the natural seasons at which they are producing in the ocean, but to be able to produce all the year around, and especially to control the quality of the biomass. I think that these technologies will expand tremendously the portfolio of algae biomass in the market. Very close to this type of technology is the microalgae production using open ponds. Of course, this is the most traditional method, but including this technology is improving a lot in the last years, especially increasing the size of the reactors. At this time, we are able to build 1 hectare single reactors. That means that the facilities are less complex, and we can build 100 hectares facilities in a more reasonable way than in the past. I want to remark also the development in construction method to be able to reduce the installation cost of the facilities, also question concerning management of the reactors, etc. But if you want to produce the best quality biomass, of course, closed photoreactor is the best option. The advantage of closed photoreactor is to be able to control everything in the production chain, and then to be able to produce whatever strain out of the more conventional, like chlorella, spirulina, etc., which are also very important now for new markets. But in the last year, also the heterotrophic production of algae appeared. Is a real option. A lot of companies are producing heterotrophically algae, like bacteria, yeast, etc., using conventional fermenters. At this time, the heterotrophic production, including overpassed the autotrophic production in Europe. But this is important also for certain applications. I want to say that none of these single technologies is the best one. Then we need to use all of them for different applications according with the final purpose. I will provide now some slides about some of companies already producing algae in Europe. I want to remark some of them, like Rocket Clothes, because in Germany this company was one of the pioneers in producing microalgae using tubular reactors. This facility is still operating, and we have a large portfolio of facilities close, similar to these ones. This plant is located in Germany, which is not very usual, because most of the tubular reactors are located in the south of Europe. I mean, Portugal, France, Greece, Italy, Spain. The Necton is another very important company with large tradition in the production of different microalgae in the south of Portugal. They are producing using tubular reactor, but also different technologies. Also in Portugal, we have all microalgae producing chlorella, basically for human application. I want to remark that using this type of technologies, the production costs cannot be reduced below 30 euros per kilo, more or less, in this range. This is due to the cost of the technology, the energy required, etc. Then this type of technologies are very important for certain applications related with high value of the biomass. We have another company also in Spain, close to Almeria, in Cádiz, producing biomass at the beginning for aquaculture, but now they move for the food and nutraceutical sector. Also in France, there are some companies producing microalgae using tubular reactors. All of them are focused not in the large production capacity, but especially in the high quality of the biomass. And I want to remark also this new emerging sector, because companies are located in the north part of Europe. They are not, they don't have the good conditions concerning sun, temperature, etc., that we have in the south of Europe. And then a lot of companies producing algae in the north part of Europe are using artificial light. This is very interesting because, of course, the cost of the electricity is a factor, but it doesn't affect too much the production cost. More or less 3 euros per kilo, in the range of 3-5 euros per kilo, they can assume. But they simplify a lot the infrastructure. I mean, they don't need so large surface. They can accumulate more volume per square meter, and they have a better control of culture conditions inside the buildings. We have different examples, also algae leaf producing nematococcus, also in Norway, and also Baxa technologies. All of them are focusing the production of high-quality biomass for mainly nutraceutical applications of the biomass. Also, Algae Seeds is a joint company between England or United Kingdom and Germany. Now, I provide some slides about the raceway reactor. These are the most conventional. In Europe, the size of the reactor is not larger than 5,000 square meters. Mainly, companies are producing spirulina, also for food application, food and nutraceutical applications. We have certain examples. This is Professor Silvio Mangini in Italy. We have certain examples in Italy. Also, this company is a company producing other fruits in the crops, and they are producing also spirulina in Italy. Another one also in Italy. All of them are producing microalgae inside the greenhouse to increase the quality of the biomass they are producing. Also, we have a large portfolio of companies producing spirulina in France. The quality of this biomass is very high. Also, the price is quite high, but the market is demanding this high-quality biomass. We have other companies also in France. Also in Greece, there are companies producing spirulina also inside the greenhouse. And in Spain, we have this company, Biomass Biotech. I want to remark that this company is not producing spirulina or algae for food application, but for biostimulants. Then this company is already exporting biostimulants produced in Spain around the world. In the last year, we have a third technology. We want to take care about this technology because it's really promising. This technology is thin layer cascades. It was developed initially in Trebon, in Czech Republic, and now several companies are able to scale up this technology, and they are producing already commercially microalgae biomass using thin layer cascade. The major difference between thin layer and raceways is the water depth. In this case, the water depth is in the range of few centimeters, 2, 3, 5 centimeters, according with the technology. Then they are able to achieve much higher biomass concentration and including productivities. We can find this type of reactors initially, or more or less starting at industrial scale, I mean, in Portugal, also in France, in Portugal, etc. I want to finalize with a topic about integration of microalgae production and recovery of nutrients. I want to remark the relevance of this topic because microalgae are very efficient in the recovery of nutrients contained in wastewaters, I mean urban wastewater, but also animal manure, digestate, etc., which in certain conditions are an environmental problem. Then instead of spending a lot of money and energy in the treatment of these residuals, we can transform these materials into nutrients for algae production. The system using algae are very simple, and there are previous experience, including not only from the academia, but also from companies, demonstrating that this technology is reliable and is very efficient in terms of biomass production, water treatment, I mean the total capacity of water to be treated. We are saving a lot of energy because conventional wastewater treatment requires a lot of energy that we are avoiding using microalgae. And we are able to transform the microalgae biomass in different products, especially using anaerobic digestion. We are able to produce energy in the forms of methane and also fertilizer for crop production, etc. This is really an important technology. We believe on this technology, and the demonstration of that is that in Spain we already have 4 different facilities treating wastewater in real municipal facility plants. I want to remark the size of the reactors. In this time, the size is in the range of 1 hectare, one single reactor, and they are operating very robustly all the year around and being able to treat the wastewater and to produce valuable products, including water, but also biomass for fertilizers, etc. This is an evidence also of the interest of this market. Bioreason Biotech is a company already selling this type of products for agriculture sector. We demonstrate that biostimulants being produced from algae are able to reduce the consumption of fertilizer in regular crops at the same time that they prevent some disease, especially fungi, and this is a very useful tool also for the control of pathogens in crops for the production of foods. I want to invite you to join to the European Algae Biomass Association. We have an annual conference in December every year. The next conference will take place in Praga. Then you are invited to come with us and to be part of this team, this association focusing in the development of the algae sector. Finally, I want to invite you also, if you are interested to go to Spain. We perform different training courses about this topic to teach about the sector, the technologies, and collaboration with other entities and research centers around the world. And that's all from my side. Thank you very much.
Thank you indeed. Our third speaker for this session is Dr. John Benneman, founder of Microbioengineering Incorporated.